Okay, my name is Maxwell Wyman. I am going to be recording. This is my Curiosity Journal 3. We're going to be discussing CFCs and the ozone layer. So a little background here about CFCs and the ozone layer. So what are CFCs? CFC stands for chlorofluorocarbon. There's also another group we will be discussing later, HCFC, which is hydrochlorofluorocarbon. They belong to the halocarbon group, and one of the most widely used CFCs industrially was Freon, which was discovered by GM in the 1920s. It rapidly came into use for a variety of purposes, primarily in refrigeration, but also in aerosol sprays, metal cleaning, spray insulation, many things. It was cheap and comparatively non-toxic to other refrigerants available at the time. And by the 1970s, DuPont Chemical was producing some 50% of the world's total Freon. So what is the ozone layer? So ozone is O3. The Earth has a layer of ozone in the stratosphere. Ozone represents a relatively small proportion of the stratosphere. It's 1 to 10 molecules per 1 million molecules in the ozone layer. Ozone and oxygen absorb some 95 to 99% of UV rays. These are high energy rays that are radiation. So it actually creates a filter that protects us from harmful radiation. So why study CFCs? So CFCs represent an ecological disaster, and they contribute to climate change. CFCs are also one of the only examples of coordinated international action on an issue, especially an environmental issue. So ozone and CFCs. So CFCs are very stable, and therefore they are difficult to break down, whereas a lot of other molecules would have broken down by the time they reached the ozone layer. CFCs do not. They're actually able to reach the stratosphere. So early 1970s, a scientist named James Lovelock discovered that almost all CFCs released in the environment were accumulating in the atmosphere. And then in 1974, two scientists, Molina and Rowland, published a paper in Nature magazine contending that CFCs react with ozone, resulting in ozone breaking down into oxygen. Ozone breakdown would result in more UV rays punching through the stratosphere. It would result in the Earth warming, as well as just more radiation hitting us. So let's look at the chemistry of CFCs and the ozone layer. So how do CFCs destroy ozone? So once again, CFC, chlorofluorocarbon. So chlorine, fluorine, carbon. And this represents a wide group of different types of molecules. CFC, mentioned CFC stability allows them to rise to the stratosphere. They are able to interact with high energy protons, and at that point they start to break down. So the chlorine in CFCs bonds with ozone, breaking ozone down into O2, thereby depleting the ozone layer. So we can see the chemical reaction of CFCs and ozone. It's really just those first 1 and 2 parts, part 1 and 2, but 3 also shows how this is a continuing cycle. So you can see the chlorine in CFCs interacts with ozone, creating chlorine monoxide as well as O2. That chlorine monoxide is then able to combine with another single oxygen, which creates just that single chlorine as well as more oxygen. Okay, so what happens then? Well, that chlorine is then able to continue this cycle. So it bonds with ozone again, and then creates more O2, and then it keeps going around and around in circles. So this creates a feedback loop where a single chlorine atom can break down many ozone molecules into oxygen. So fighting CFCs became kind of a problem. Again, DuPont Chemical was the widest producer of CFCs in the world. That being said, there were other chemical producers that also made CFCs. Many were in Europe as well. So DuPont was aware of the hazards of CFCs as early as the 1970s, right when that paper was published in Nature magazine. So their response was, first off, deny everything. So the production of sales of CFCs was extremely profitable for DuPont. We're talking hundreds of millions of dollars per year. So DuPont just started a PR campaign disputing the hazards of CFCs. So they started with newspaper advertisements stating that CFCs did not deplete the ozone layer, that they were non-hazardous. They started attacking and discrediting scientists that were studying the hazards of CFCs. They ordered and published biased studies about CFCs that were not peer-reviewed. It was a classic, we have a conclusion, so let's go find the evidence to support the conclusion, the backward study. They lobbied lawmakers to prevent CFCs from being regulated. Notably, President Ronald Reagan was a big friend of preventing the regulation of CFCs. They also argued about the economic consequences of CFC regulation. So once again, this is a billions of dollar industry. So regulating CFCs would result in that being limited. So then DuPont had a shift. So in the late 1970s, DuPont's patent on many different CFCs was coming due. So they had patents on CFCs, but those patents were up. Also in the late 1970s, early 80s, DuPont discovered that there were cheaper, more profitable alternatives to CFCs that can be used for refrigerants and just replace a lot of the same mechanisms that CFCs were using. The 1980s, DuPont does, like I said, a complete about-face and then starts to argue that CFCs did, in fact, deplete the ozone layer. So they started to do this after it became clear that they were going to face competition in production of CFCs, and it became clear that there were cheaper and therefore more profitable alternatives to CFCs that they could produce. So let's talk about fighting CFCs, the Montreal Protocol. So as I mentioned, this was a great example of international coordinated action to fight something. So the Montreal Protocol was introduced in 1987. There have been many amendments since 1987 to the agreement. It was an international agreement to regulate and prevent the use of CFCs. So 107 countries, as well as the wider EU area, have adopted the Montreal Protocol. So very, very many countries. The goal was to gradually phase out, quote unquote, the use of CFCs by about 2013, starting with developed countries. So what do I mean by developed countries? I mean that in the developing world, the protocol actually allowed for the continued use of CFCs in developing countries until 2010, and it allowed for the continued use of HCFCs in developing countries until 2040. Now that has gone through a series of amendments, but this is what I mean by developed countries. So I want to talk real briefly about treaties, deep versus wide. So a treaty can come in two different forms, or not two different forms, but a treaty can have two facets. It can be deep, which requires a lot of things from whoever signs it, so it requires a lot of actions, or it can be wide. So in other words, many signers onto the agreement. So the Montreal Protocol is a pretty classic example of a wide but not particularly deep treaty, right? So we got all of these countries to sign it, but what were they doing? Well, they were agreeing to stop doing CFCs, but CFCs were already not particularly profitable, and a lot of the countries that were signing it were developed countries, and the developing world didn't really have a big foot in producing CFCs, so it's not particularly deep. It doesn't require a lot from the signatories. So again, Montreal Protocol was created only after it was no longer expedient for chemical companies to produce and sell CFCs. And again, it's also the preference of the developed world over the developing world. The developed world produced CFCs and HCFCs. They were the culprits for depleting the ozone layer. And yet the developing world continued to have CFCs sold to them and used, despite the fact that we knew about the hazards. My works cited, a lot of different ones here. Please feel free to reach out if you have any questions about those.